Şu an ekranımı görebiliyor musunuz hocam?
Görebiliyorum hocam. F5 yapıp devam edin hocam.
Good morning all. I'm İsmail Akta. I'm doing my Electrical and Electronics Engineering Master's degree at İzmir Katip University. I'm working in a field of RFID systems, RFID antenna designs, and also I'm developing end-user applications for RFID systems. My study is about estimating scattering parameter of UHF band E-shaped RFID patch antenna. I'm participating as a speaker, and the other contributors are Cem Göçen, Melih Palandöken, and Adnan Kaya. Here is my presentation outline. First, I'll give a brief information about the importance of antenna designs, usage areas of machine learning techniques, and RFID systems. Then I will introduce the E-shaped RFID antenna design, which found in literature. Then I will talk about the machine learning model and dataset. I will show numerical results, comparison, then conclusion and future works. With developing technology, the dimensions of electrical components will be a more important issue to solve. The size of these components decreases rapidly, and for that reason, it is necessary to design these components smaller and compact size. In wireless systems, antenna is a crucial part because you can't transfer any information without an antenna wirelessly. As a result, for small and compact wireless systems, antennas have to be designed smaller. However, during the development phase, the reduction of the size is possible as a result of trade-offs with the performance parameters of the antenna. Machine learning is the computer modeling of systems that make predictions by making inferences from data with mathematical and statistical operations. Machine learning algorithms can be applied to many different areas such as engineering, science, medicine, and economics, and provides accurate results and evaluation. Antenna design is also a set of mathematical and statistical works. Any geometric changes made on the antenna directly affect the performance of the antenna. Antenna designs usually carried out with the help of 3D electromagnetic simulation programs such as CST Studio Suite, HFSS, etc. There are many parameters that need to be examined to find out the operating frequency of an antenna. One of them is the scattering parameter. Scattering parameter is a parameter that can show us the antenna's resonance frequency, so we can understand the antenna's operating frequency by examining scattering parameter. And these simulation programs provide validated data on the performance parameters of antenna. So the scattering parameter of an antenna can be learned with using these 3D electromagnetic simulators. But generally, the duration of simulation times of these programs is too long in complex structures. So the motivation of this study for a complex UHF RFID antenna, estimating the scattering parameter with using machine learning algorithms and data obtained from CST Studio Suite, so we can save the simulation time. I also want to mention about the RFID systems briefly. The RFID is an acronym for radio frequency identification. And in simplest way, we can identify and track RFID tag-attached objects with using radio waves. You can see in figure 1 the main three parts of an RFID system. RFID reader sends signals with the help of RFID reader antenna to RFID tag, and RFID tag sends back a signal with the information in its chip with its antenna. RFID systems can be used in many areas such as access systems, staging units, supply chain, animal tracking, etc. And the reader antenna is an important part of RFID system. In the study, E-shaped RFID antenna design found in literature has been used for estimating scattering parameter. This antenna consists of three simple elements: modified half E-shaped patch, corner truncated square patch, and four rotated metallic plates on the edge of the ground plane. You can see the design parameters of this antenna in table 1 and what these parameters mean in figure 2. The scattering parameters of the E-shaped RFID antenna design were calculated in the CST Studio Suite program with the values in table 2. There are total 2,592 samples exported in CSV file formats for using machine learning algorithms. You can also see the necessary information about changing parameters in table 2, like change rate, step size, number of samples, and parameter. For using in machine learning model, the linear scattering parameter and the complex scattering parameter have been used as outputs, and the antenna design parameters, which are shown in table 2, have been used as inputs for both models. While the linear scattering parameter has one value, the complex scattering parameter has two values, real and imaginary part. Because of this reason, for complex scattering parameter, multi-output regression technique has been applied. For implementing machine learning models, the Python programming language has been used with necessary packages, as you can see in here: scikit-learn, pandas, matplotlib, and plotly. Scikit-learn has different regressor libraries such as polynomial, Bayesian reach, random forest, gradient boosting, voting, and multi-output. Voting regressor is an ensemble type regressor which can use multiple regressors for analysis. Then it averages the individual predictions to form a final prediction. And polynomial, Bayesian reach, gradient boosting, and random forest regressors have been used together in voting regressor. And multi-output regressor is a regressor that can be used for multiple output values. As I mentioned before, this regressor has been used for estimating complex scattering parameter. In the numerical results section, I will show you the R-square results obtained from different regression techniques and the estimated and actual output results for 20 random output values. Scikit-learn has been used for implementing regression techniques. Pandas has been used for editing the data obtained from simulation program. Matplotlib and plotly packages have been used for visualize the result data. Train and test data divided by 33% and 66%. Okay. For 6-degree polynomial regression, the performance results shown in the table, and the graph shows that the actual and predicted output values. The orange ones are predicted output results, and the blue bars are actual output results. This method has 99.91% R-square value. Also, you can see the other performance parameters like mean absolute error, maximum error. For random forest regressor, the R-square 99.29%. For Bayesian regression methods, the R-square is 83.64%. For gradient boosting, 99.69%. For voting regressor, 95.66%. And lastly, for multiple output regressor, R-square value 98.66%. And here are the test input parameters and predicted and actual output values for multiple output regression. You can see in the table. The performance comparison of all regression techniques is presented in this slide. When the results of the test data were examined, it was observed that the best prediction performance was obtained in the polynomial regression technique. However, when all performance data is examined, R-square is above 99% in most of the regression methods. Since the high degree of polynomial regression may negatively affect the estimation performance, it may be more logical to use random forest regression or gradient boosting regression at this stage. At the same time, a value of 98.66% R-square value was obtained from the multiple output regression method. By increasing the number of samples of the dataset used in the study, much more accurate results can be obtained. At the same time, using the predictive performance of machine learning, the study can also be applied on different antenna designs, supported by different methods, and an antenna calculation tool can be created for future studies. Here are my references.
Hocam katkılarınızdan ötürü teşekkür ederiz.
Thank you for listening.
Arkadaşlar sorumuz var mı? Peki. Tekrar teşekkür ederim hocam katkılarınızdan.
Ben teşekkür ederim hocam. İyi çalışmalar.
İsmail Öztürk hocam burada mı?